Okay, the one-to-one function f has domain x is less than 0, negative, and is defined by f of x is 2x squared plus 1 over 2x squared plus 5. Show that f dash of x is always negative. So remember now, f dash of x, looking at differentiating it, like dy dx. We need to differentiate this. Now, when you differentiate this, we have to think of it as a quotient, because that's what it is. In case we need to use the quotient rule to differentiate, that's the only way we can do it. So with the quotient rule, you set u to equal the top function, v to equal the bottom function. So you differentiate the top one, so you differentiate the u, so u is 2x squared plus 1, du dx will be 4x, and then dv dx will also, when you differentiate this, you'll also get 4x here with that. Okay, so when you do the quotient rule then, if you remember for the quotient rule, dy dx, we write it as, don't we? It's the same as f dash of x is v du dx minus, okay, u dv dx. Okay, so always a minus, isn't it, when you do the quotient? But also, you've got to divide by v squared. So when it comes about doing this, then you sort of crisscross, don't you? So it's that times that. So 2x squared plus 5 times 4x. Take away then u times dv dx, so 2x squared plus 1 times 4x. Okay, and that will equal to then, multiply this out, so you get 8x cubed plus 20x. Okay, of course I'm forgetting here to divide by, I've done the top there, and divide by v squared, haven't I? Which would be 2x squared plus 5 all squared. Okay, so then when it comes to sorting the top out, times them together, so you get 8x cubed plus 20x, and then you've got to times this bracket out. That's take away 8x cubed, because we've got a minus there, and then take away 4x. Okay, that's all over the v squared. Remember, v squared in the bottom, you don't touch it, you leave it as it is. On the top then, notice how nicely they cancel. Okay, and then 20x take away 4x will be 16x over 2x squared plus 5 all squared. Okay, now what's great about this is then you've got your f dash of x, and you've got to show that it's negative, you know, and you look at that and think, well, how on earth am I meant to do that? But you always refer back to the domain of f, and if you remember, domain of f, x was less than 0. Okay, has x negative. Okay, so if x is negative, you've got to think what 16x is going to be. Okay, so therefore 16x is going to be less than 0, isn't it? Okay, that's how you look at it. You look at the domain, what values it takes on. It's taking on negative values for x, so that means 16x is less than 0. The bottom, of course, that's always going to be positive, isn't it? Because when you square something, it's always positive. Okay, the square of anything is going to be positive, right? So you have negative on the top, positive on the bottom. When you divide negative positive, it leads to a negative answer. So therefore, f dash of x is always negative. You proved it, okay, for every value of x, okay, in our domain here. Now, you might be wondering again, why is this in a function question? But it will help us when it comes to working out the range. Because if f dash of x is always negative, we've got a curve which is completely sloping downwards. I mean, I don't know what it looks like, right? I haven't got a clue what it looks like. And you know, you're not meant to know what it looks like, but it's always sloping downwards. You've always got a negative gradient. It's not all of a sudden going to start increasing, okay? Because that would be positive. That's not going to happen, okay? It's always going down. And if it's always going down, always decreasing, what we can say then is that the lowest value in the domain will give me my highest value in the range, and my highest value in the domain will actually give me the lowest value in the range. Okay, we've got the domain, haven't we? X is less than 0. Okay, so the lowest value in that domain will be minus infinity. Okay, minus infinity will be the lowest value in that domain, and the lowest value in the domain which should then give us the highest value in the range. So let's just work that out. I'll do it here. Like if we take the lowest value, which is minus infinity, put it into the function we've got. So we're going to put minus infinity all squared plus 1 over 2 minus infinity all squared plus 5. Okay. Now the fact that you're squaring it here makes it positive infinity, doesn't it? Timesing it by 2, adding 1 doesn't make much of a difference really. So you're going to end up with infinity on the top. And the same on the bottom then, isn't it? Okay, adding a few extra doesn't make much of a difference. Infinity on the bottom. And when you share infinities, okay, infinity divided by infinity, well, it's 1, isn't it? Okay, it doesn't matter because it's infinity, right? The fact it's infinity, that makes no difference. If you're dividing infinity by infinity, something by itself is still 1, okay? So if you think back to what I said earlier, the lowest value in the domain, which is minus infinity, will give me the highest value in the range. So this should be the highest value. Put the highest value in the domain then, which is 0, okay? Well, not quite 0, but 0 goes towards, doesn't it? Tends towards 0. That would be 2 times 0 squared plus 1 over 2 times 0 squared plus 5. And that will be 1 on the top, 5 on the bottom, okay? So that's our lowest value, isn't it, in the range. So our range will be 1/5, okay? And I put a square bracket there, shouldn't I? Okay, a round bracket should be 1/5 and 1. Both round brackets because these values weren't included, obviously. Find an expression for the inverse function. Okay, so part C now. Find an expression for that. So the first thing we do is rewrite this as, okay, remember what was on the top there. Rewrite it like that, and we want to get x equals. So what we do then is, we take this up here, okay, leave the y where it is, you're going to have to, okay. You know, if you take the y down there, you're going to be stuck then with 2x squared plus 1 over y, right? The algebra here is a lot more complex, but because you've got x squared on both sides, but that's okay. We can deal with that. Okay, we're just going to get the x's together. So multiply out by y here. 2yx squared plus 5y equals 2x squared plus 1. Get the x's onto one side. So I'll keep the 2yx squared where it is, but take that 2x squared over. I'm left with 1 here, and take that 5y over. This becomes minus 5y. Now on this side, remember on x, so I'm going to factorize out x squared. It's a common factor. So I have 2y minus 2 equals 1 minus 5y. Okay. And then x squared, of course, is times in this bracket. So I can take that bracket over and divide. And I get that. Okay. And then you go for plus or minus. You could take the square over, square root, plus or minus. Okay. And if we remember, the domain here of f was negative, wasn't it? Okay, remember it was like x is less than 0, that was the domain. So that means then you therefore take negative root. Okay, so therefore f to the minus 1 of x will equal negative root 1 minus 5x over 2x minus 2. Alright? And then I think at the end it says the range and domain. Well, we all know now the range of the inverse will be the domain, okay, the original function, and then the domain will be the function of the inverse function will be the range, which was 1/5, 1, okay, of the original function. And we've answered the question.